Guys, I hope everyone's doing well in week two. What we're going to be doing today is finishing off the stuff on functions and graphs. The last one's going to be on functions and modeling. The first bit's going to look pretty similar to stuff that we did back when we did like linear and quadratics. The question's essentially the same sort of deal with some new bits added on. I'm going to go through this one example and then I'm going to go through two questions just so people have a bit of a broad sense of exactly what you're going to be working on this lesson. So first question, first example says that we've got a householder who has six hens. I don't think the six hens actually matters for the question, but whatever. Wishes to construct a rectangular enclosure to provide a maximum area for the hens using a 12-meter length of fencing wire. Looks very similar to questions that we've seen in the past. It's For question A, it's asking if the length of the enclosure is x meters, find the width of the enclosure in terms of x. So we've done this in the past. There was a question on this about on the last sack that we did. A few people had a bit of a tough time with it, so it's worthwhile taking one more swing, see if we can get good hang on it. So what we've got is a length of 12 meters, and we've got an enclosure with a length of x meters. So we can visualize this as it's going to be a rectangle. The length is going to be x, and the width we can represent as being w. And because the perimeter is 12 meters, all those four sides have to add up to 12. So 12 is going to be equal to 2 times x, 2 times the length, plus 2 times the width as well. The four sides combine to get us 12. So we're asked to find the width in terms of x. So if I take my equation, I can rearrange it and say that 2w is going to be 12 minus 2x, taking away 2x from both sides of my equation. And lastly, to figure out what w would be, I can divide both sides by the 2. So if I divide everything by 2, I'm going to get w equal to 12 divided by 2 is 6, 2x divided by 2 is just x. So the width is just going to be 6 minus whatever the length happens to be. This is just getting our first questions answered. Now, question B is going to hopefully look kind of similar as well. We're asked to construct a function that gives the area of the enclosure A in terms of its length x. So to figure out the area, we should know for a rectangle the area is going to be length times width. And we know that the length is going to be x. X is what the length happened to be. So that's our length. It's going to be times by the width. And we know from above that the width is going to be 6 minus x. So we can just put that in. Length is x, width is 6 minus x. We times them together, we've got our area function. So we've seen this before, and hopefully this is just a bit of a refresher. Now, what we're asked to do next is take that area and plot that over a suitable domain. So what I can do first of all is I know that this is x times 6 minus x. If I expand out these brackets, it'd be 6x minus x squared. We've got a squared graph, we've got a parabola, that's what we're expecting to get. It's got a minus sign in front of the x squared, so I'm expecting it to be like one of the upside down frowny face ones. So what I can do first of all is I can figure out where my graph is going to go. I know that if my equation looks like this, then I can use what we call the null factor law to figure out where the x-intercepts are. So to get my x-intercepts, I know that either x is going to be equal to 0, either this is 0, that's one of my x-intercepts, or this is 0. So if 6 minus x is 0, then x would have to be equal to 6. So they're the two ways I can get this equal to 0. Either x is 0 or x is 6. So my 2x-intercept is going to sit here, and they're going to sit here. Now, we've got to kind of visualize how this is going to operate. We're talking about the x is the length of an enclosure for a rectangular like enclosure. So it can't really have a length of 0, and it can't really have a length of 6 because then like the width would be 0 as well. So I'm going to exclude those 2 points, those 2 endpoints from my domain. It doesn't make sense for a rectangle to have a length of 0, so that's not going to be included. But there's going to be basically where my graph will start and end. I'm expecting my graph to go like up and back down. So if I was to extend it past that into the negatives, I'd be talking about a negative area. That doesn't really make sense. That's a good place for my graph to start and for it to end. Now, next thing I'd want would be my turning point. Since I've got my x-intercept at 0 and 6, halfway in between those is going to be 3. I'm probably going to draw that, but I can figure out that the x-coordinate of my intercept is going to be at x equals 3 of my turning point. So My turning point is going to be at x equals 3. To figure out what y coordinate it's going to have, I can take that value of 3 and I can put that into my equation up above. So the y coordinate is just going to be, or I can just write down y. Y is going to be x equals 3 times 6 minus 3. So 3 times 3, that's just going to be 9. So my turning point is going to be x equals 3, y equals 9. It's just going to sit up here. Now I'm going to try and do a decent job of drawing my parabola. First half is good, second half's decent. So I've got my parabola drawn out. It's over a suitable domain. It's got everything it needs. I might also just want to label my points just to make sure I'm being like completely formal. And then I should have everything that I need. So this is my graph. It's just the area and how it changes based off x, which is the length. Now, what I'm asked to do next is state the domain of the area function. So I should know that the domain is just the x values. So I can say domain of x, or domain of a, sorry, is going to run from 0 up to 6. Those are the x values that my graph covers. We've said that it doesn't include 0 and it doesn't include 6. So we've got to stretch it from 0 to 6, but we use round brackets because 0 and 6 aren't included in my domain. So that's how my domain is going to look. Now, for the final question, you're asked to find the maximum possible area of the enclosure and the dimensions of the enclosure. That should be pretty easy. We know the maximum area is going to peak at 9. So 9 is going to be the maximum area that my enclosure can have. So I can just write out maximum area is going to be 9 square meters. I know that that's going to be the case when I've got x equal to 3. So the dimensions would be that I'm going to have x equal to 3. X was the length. So the length would be 3 meters. So 3 meters long. And if I want to figure out what the width would be, I can scroll back up. I can see that width is 6 minus x. So if x is 3, then I can figure out that the width is going to be 6 minus 3. So width equals 6 minus 3, also going to be 3 meters. So it ends up being a square, but that's still kind of rectangle, I guess. So the questions look like this. Hopefully this is ringing some bells about stuff that we've done in the past. But yeah, there will be a couple questions like this today, and it is going to sort of follow that sort of similar process. Now, that's the example from the notes. Also wanted to go through 2 questions just because they're a little different, and there'll be a few like these, so it's probably worth going over them. You might want to write these down in like your writing books where you write your answers as we go through these ones, just because like we'll eventually have to answer them, so why not do so when we're going through them. So it says that suppose that Unanistan Post charges the following rates for airmail letters to Africa: $1.20 up to 20 grams, $2 over 20 grams and up to 50 grams, $3 over 50 grams and up to 150 grams. If you're wondering where Unanistan is, I looked it up and it's apparently an old name for Greece. So, like, there's a fun fact. What we're asked to do is write a cost function C in terms of the mass M for letters up to 150 grams. So we're going to write a function. It's going to be called C. It's going to depend on dollars. Or just C dollars. Actually, I might not even include the dollars. Dollars just doesn't make sense. I'm just going to have C depending on the mass. Sorry, that's a better way to do it. Depends on the mass, so mass is what should go in the brackets. It's going to be a function that is a hybrid function. It's going to have 3 parts to it. It's going to cost $1.20 when the mass is up to 20 grams. So for $1.20, it's going to have a mass which is bigger than 0, otherwise you're not really sending very much. The mass is bigger than 0, but it's up to 20 grams. So this is the first part of my hybrid function. It doesn't depend on the mass, it's just the rate is $1.20 for anything up to 20 grams. So just a flat $1.20. Then we've got our $2 cost for masses which happen to be more than 20, up to 50 grams. And then we've got our final one, which is going to be $3, which is going to be for anything that happens to be over 50 grams, up to 150 grams. So it's our cost function. It doesn't really depend on the mass in the sense of like the cost is either $1.20 or $2 or $3. the next question we'll see that will be a little bit different. But this is going to be our cost function. We've got it written out in three parts because there are three parts to how the cost operates. Now, once we've got that figured out, we're asked to sketch the graph of the function staying the domain and the range. So I'm just going to draw up some axes. I might just label this as A so that I know that I've got that one answered. What I'm going to do is draw up some lines. I probably don't need the negatives because it starts at 0, but I'm just going to put them on there anyway. Looking at my horizontal, it's going to go up to 150, so I expect on my horizontal it's going to have to like cover that area. Just for convenience's sake, I might go up in 20. So 20, 40, 60, 80, 100, 120, 140, 160. Get those labeled real quick. They're not as well spaced as they could be, but like hopefully not going to make too much of a difference. I'm going to label this as being the mass, which is going to be in grams. And then on the vertical, it's going to go up to $3. So I might put $3 at the top and then try to split this into some nice thirds, $1 and $2. I'm just going to label this as the cost in dollars. So I don't really need the bottom parts of my graph, but I'm just going to leave them sitting there either way. So what I've got first is when the mass is bigger than 0 and up to and including 20, it's going to cost $1.20, a flat rate. So if I go up to $1.20, I'm going to draw a open circle at that spot to show that a mass of 0 isn't included. And I'm going to draw a line that goes up to 20 that's going to try and be a flat line. So between 0 and 20, it's going to cost $1.20. That's the first part of my hybrid function. The second bit is when it's between 20 and 50, it's going to cost $2. So going up to $2, drawing an open dot above 20 because it doesn't include 20. Drawing a closed dot up at 50 because it does include 50. $2 being the second part of my graph. And then the obvious part for the third one is it's going to start at 50. It's going to be $3. So draw an open dot there, going all the way across to 150 grams. Try and get this to be a nice straight line. This is going to be the third part of my hybrid function. It does include 150, so I've got a closed dot at the end. So this is going to be my hybrid function as it's drawn out, having sketched the graph. Now I just need to state the domain and the range. So the domain, again, is just going to be the x values that it can have. So the domain of C is going to be that it stretches from 0. It doesn't include 0, but it starts there. And it goes up to 150, including 150. So the domain of C just being from 0 to 150. Now, for the range is the y values that it can have. It can only take on 3 y values. It can either be $1.20, or it can be $2, or it can be $3. So I'm just going to write those out as my possible values that I can have. $1.20 for probably 2 next, or $2 or $3. It's just a set of 3 numbers rather than being a range because that's just the way the graph is. It can only have 3 y values for the cost. So I just draw it out in that particular way, showing what values it can have. So that's question number 2 done. It just involves figuring out the hybrid function, sketching it, and then using it to get the domain and range. The next question we're going to go through is a pretty similar one. Some differences though. So it's got self-travel, a car rental firm has 2 methods of charging for car rental. So 2 ways that they can charge for cars. Method 1 is they charge $64 per day, plus an additional 25 cents for every kilometer that a car happens to travel. That's one way they can charge for cars. Method 2 is just pay $89 per day with unlimited travel. Doesn't matter how many kilometers you travel, it's just going to cost you $89. So rather than being a hybrid function, this is just 2 different functions, and we're just going to write them out and compare them. So what we're asked to do is write a rule for each method. If C1 is the cost in dollars for using method 1 for X kilometers traveled, and C2 is the cost using method 2. So I'm going to have 2 functions. C1 is going to be C1 of X, depending on X. It's going to cost $64 per day, so just a flat $64, plus an additional 25 cents or $0.25. Times X, which is the kilometers that they travel. So since the 64 is in dollars, the 25 has to be in dollars as well, 25 cents being 0.25. That's why it's like written in that particular way. So this is our first cost function. This was method number 1. Now, method number 2, it's just going to be a flat rate of $89. So it's not going to depend on X. It's not going to depend on the distance traveled. So it's just going to be 89 for my cost. So this is going to be my answer for A. Now what I'm asked to do next is just to sketch those two methods out on a set of axes. So again, it's going to involve drawing graphs. I'm just going to draw a nice big set of axes. And again, I don't really need the negatives, but I'm just going to put them on there either way. What I might do is I might take my graph from, say, 0 to, what's a good number, 100. So 100 would be 20, 40, 60, 80, 100. So 20, 40, 60, 80, 100. And on my vertical, I might take this up to 100. Halfway up would be 50. And then try to get these evenly spaced 10, 20, 30, 40. And then 60, 70, 80, and 90. Just leaving those on there. So this is going to be X. This is going to be distance traveled. So I can say either X if I want, or I can just say distance traveled kilometers. And on the vertical, we're going to have the cost, which is going to be in dollars. I'd say that this is in kilometers as well. Now, I want to draw both my graphs. I'll start with the easiest one, which is the second one. It's a flat rate of $89. So I look at where 89 is. It's going to be about here. And it's going to be $89 regardless of how long they drive for. So just a nice flat line, $89 cost. Doesn't depend on the kilometers traveled, so it should be just a nice straight line. That's my second function drawn. That was C2. Did the easiest one first. Didn't have to think too hard about it. For my other function for C1, I can find 2 points for my graph. It's going to involve X, so it's going to be a linear graph. I can find where it's going to start and end on my axis. So to figure out where it starts, C1 of 0, when X is 0, is going to be 64 plus 0.25 times 0. That comes out to $64. So it's going to start at 64, which is just going to be down here. That's going to be one of the points that I need to draw my graph. To figure out where it ends, oops, sorry, that'll be C1. C1 should be at 100. So that's going to be 64 plus 0.25 times 100. 64 is 64, and 0.25 times 100 is 25. So this comes out to, what do you know, $89. So it's going to end at $89, which happens to just be up here. What a coincidence. I'm just going to connect those up. This is really hard to do with an angle. Straight line, perfect. This is going to be C1. So I've got my two graphs drawn out, and that's what I was needing to do for question B. Now, for question C, determine from the graph the distance which must be traveled per day if method 2 is cheaper than method 1. So basically it's asking where do the graphs meet. Up until here, you can see that method 2 is more expensive than method 1. Method 1 is down here while method 2 is up here. And then what will happen is eventually they're going to cross at this point, past which method 1 would keep going up. It would become more expensive and method 2 would be cheaper. So basically where do they cross? I should know that like they cross at like when they cost $89, which is the 100 kilometer mark. That's where I found that they're going to cross each other. So I can say that as long as X is greater than 100 kilometers, in that case, I'm going to have the second method cheaper than the first method. If my graph wasn't set up so nicely and I had to actually figure that out the long way, what I'd do is I'd write down method 1. I want method 1 to be greater than method 2. So that would have to be greater than 89. I can do a bit of rearrangement. I can take away 64 from both sides and get that this would be bigger than 25. Then I can divide by 0.25 on both sides, and I would get out X bigger than 100. Same result, just using an inequality rather than actually drawing it out. So a lot of the questions are going to look like this, where either you've got to take your information and use it to create a hybrid function. Basically, if it's going to be like it costs this much for this much and this other amount for a different amount, if it's going to be spaced out in different intervals, then we'd have a hybrid function. Sometimes though, we've just got two different functions that we're going to compare. A lot of the questions are going to look like that. So what I'm going to get you guys to do is we're working on 5H. We've gone through questions 3 and 4, I think it was, or was it 2 and 3? It was 2 and 3. So we should have the answers to the first two done. The next couple questions are going to look pretty similar, follow similar strategies. Question 8 is kind of a doozy. It's basically like you've got a rectangle and you've got to find the perimeter and area of it. So that's kind of a bit of a challenge question, but hopefully you guys will have time to get to that one. That's the plan for today. Just got to try and get those questions done.